All right, today we're going to talk about addition and subtraction inequalities. Yesterday we talked about writing and graphing inequalities and just basically trying to understand what an inequality is. Today we're going to talk about how to solve addition and subtraction inequalities. It's pretty much the same as solving one-step addition and subtraction equations with just a little difference at the very end. The first step to solve any equation or inequality is always to write it down. So we're going to write the inequality down. Our second step is going to be to show the inverse operation under both sides of the equation. Step number 3 would be to solve, and by solve I mean do the math involved in the inverse operation. And here's the different part. We're going to graph it on a number line today. So let's take a look at a few examples. I think you'll find this fairly simple if you follow along with me. Here we have the inequality m plus 5 is greater than or equal to 10. Well, to the variables here, m, they're adding 5 to the variable. To isolate it, we need to do the inverse of adding 5, which is to subtract 5 from both sides. When we do so, we isolate the variable because plus 5 minus 5 is 0, so that just leaves m. So we have m is greater than 10 minus 5, which is 5. So our solution would be m is greater than or equal to 5. We're going to graph it here just using a snapshot of a number line. We know our solution is 5, so I'm going to put it here in the middle. And then I'm just going to put the numbers on either side as they would appear on a number line. So here's our snapshot, 4, 5, and 6. And we're going to graph our solution. In this one it says m is greater than or equal to 5. So that means that 5 is part of our solution. So we're going to put a solid dot on 5, and then we're going to shade it going to the greater than direction. We can always check this by taking a number from the shaded area and plugging it in for our variable. So we can plug in 6 here. So is 6 greater than or equal to 5? Certainly. It's greater than 5. Since this was an or equal to, we could also plug in 5 for this one. Is 5 greater than or equal to 5? Yes, it's greater than. So we've graphed this one correctly. On our next example, we've got negative 10 is greater than x minus 12. Well, here's the variable x. They're subtracting 12. To isolate it, we need to do the inverse operation, which would be to add 12 to both sides. Over here on the left-hand side, negative 10 plus 12 would be a positive 2. Over here, if we take away 12 and then put it right back, nothing happens, so we've got x isolated. So our solution to this one would be 2 is greater than x. Now on the first one we did, the variable was on the left-hand side. And that's when we go to graph it, it's easiest if that variable is on the left-hand side. So here's what I want to ask you. Is 2 is greater than x the same thing as x is less than 2? Certainly, it sure is. So let's use this one here to do our graphing. Since 2 is our solution, we're going to put 2 in the middle on our snapshot of our number line, and then just put the numbers on either side. Since 2 is our solution, that's where we're going to start, but this time it just says it's less than 2. So 2 would not be part of our solution. 2 would not make our inequality true. So instead of a solid dot, we're going to go with a circle, and then we're going to shade it to the left because it was x is less than 2. One final example for us today, and I just kind of threw this one in because it's just a practice on combining some like terms. On this one, it looks like a two-step, but once we combine our like terms, okay, because there were 3 terms over here, and if there's 3 terms, we need to check to see if we can combine. Well, there's no other variable term than just t, so I'm going to bring the t down. I'm going to go ahead and combine, which means to add the 17 and the 45. So that's going to give us t plus 62 is less than 85. From here, we just follow our steps. Here's the variable, they're adding 62. The inverse of adding 62 is to subtract 62. When we do so on the side with the variable, it cancels out, and we're left with t is less than 23. Since this says t is less than, not less than or equal to, we know we're going to use the open circle. It's less than, so we're going to shade it to the left. So this would be our solution. Remember, we can take 22 and plug it in because it's in the shaded area to make sure we shaded it in the correct direction. So if I plug 22 in for t, 22 is less than 23. Is that a true statement? You bet. So, guys, I hope this helps you on today's assignment. And as always, reach out if you have any questions.